Jim?
Yeah, I guess I'm a good fan of pragmatism and practical implementation. So we see a lot of standards out there, and then we see a lot of applications that purport to adhere to standards but are flawed in terms of their implementation. So I think it's important to follow standards, to look at cryptographic key strengths, et cetera, but now when it goes to doing an implementation, again, but pick on the random number generation issue as a prime example, it's easy to mess up. And so I'm not sure that, I mean, I think there's an overemphasis, it seems to me, on FIPS standards and that sort of thing, and an underemphasis on, look, is it a good design? Have you missed any issues? That's code reviews and people knowledgeable in the field designing the right systems.
So we're down into the levels of chip level and firmware level kind of design in this discussion. And for our audience here, how many of you consider yourselves experts on chip level and firmware level types of design? Got a couple of you. Okay, you're comfortable in that area. That's good. I think some of the rest of the audience, though, is more familiar with the IT side of the house. Is that a fair statement? So how, one of the previous questions in the other panel talked about, in many cases, these devices that we're incorporating into the smart grid aren't even designed in-house. They're not designed by the utility. They're selected by an integrator, brought in from the outside, kind of dragged to the party. How does a utility ask the right questions to be able to figure out what the right answers are? I mean, there's a level of trust with their integrators, obviously, but how do you get from where these guys are familiar with provisioning and management of networks to a point where they can introduce these devices in a secure manner? What kind of questions are we missing? Kind of curious how you would coach these guys to select. You're 2 or 3 steps removed from most of these folks in the supply chain is what I'm asking. How would you educate them so they ask the right questions? I'll let whoever wants to go first on that one. I see a lot of Chris is sort of.
Well, I think that the certifications and the standards are a place to start for sure. Like I said before, that sets the lower, that lets you define what the body of knowledge is out there today. But as Jim says, it does not mean that you've got an absolute secure system. You then got to work to get involved in some of those standards groups, to learn and educate yourself about what's going on there, learn what makes really good security so that you can interact with vendors like ourselves and probe us that way.
Sammy?
Actually, it's today the state of knowledge of utility companies are not different than the state of knowledge of bankers in technology, right? And they tend to manage this effectively. And how they do it is, again, there's alliances that build specifications with different participation from banks and from the industry. At the end, these specifications are referred to when they want to purchase a product, and these specifications are tested with test houses that are certified or like accepted by those banks. Similarly, with operators, telecom operators, they issue the SIM card with the ID of the phone. It's a similar process. The telecom operator owns the identity of the phone. The bank owns the credit card, and in terms of government, the government owns the ID that's in your passport, or in some other countries in the identification card, or the driver license. And all of them do it the same way. They have some alliances building specification, and against the specification you have test houses that qualify against them, and they just do reference. You have to comply with this spec and get certified here, and don't need to go too deep into the knowledge. They need just to guide that process into that level of maturity.
Okay, we heard about some of that from the earlier panels. Jim, got some thoughts?
Yeah, I guess I agree, and I disagree a little bit with the last statements. I guess in terms of that, I think it's a moving target in terms of the maturity of this industry, and you'll see that a lot of the security expertise is coming from ex-NSA, basically other market areas. The telecoms area is a good example of people coming in from the smart card world and bringing their expertise and knowledge to the smart grid. So I think you're seeing that evolution of understanding of basically applying security technology to this marketplace. You'll see the leaders in industry, so the very big utilities that can afford to invest the most resources are coming out with the best solutions. And I think over time you'll see the smaller utilities, the ones with less resources, they're going to have to effectively refer to solutions that the other guys have blessed. And so some of that's going to be through vendor selection of, here's the RFP, people have gone through it, the big guys have put out the thick RFPs with all the security specs, and the smaller vendors aren't going to be able to afford that. They're going to have to refer to industry standards, guidelines, and then again, refer to their peers to understand what things do I need to look for.
Interesting, interesting. That hits on a number of themes, the information sharing aspect of it. I think earlier we had our TVA panelist was from the DoD. Jim McElroy with Green Hills was referring to their NSA certification. Sammy and you all have been talking about smart card, banking, financial types of authorizations. So let's talk about that change for a minute, though. And I want to start with Jim from Certicom because you're part of RIM. And you know about the mobile phone transformation, and you know that a lot of the consumers, a lot of this smart grid transformation is about consumer behavior and how they're actually going to deal with their smart meter and their smart appliances in the house. How do you see mobile devices fitting into this picture, and what does that mean for security?
I think mobile devices are generally, I see them as consumers of smart grid information. If you look at the telecoms network, certainly that's carriers or participants in the smart grid. They're providing services. They have, I think, fairly deep knowledge of how to secure their networks, what kinds of issues they want to address in providing that secure transport, end-to-end security, reliability, I guess multiple paths. From the mobile phone perspective, again, definitely people want to take their mobile device and connect it up and view their energy consumption. They might want to manage, do some demand response, do that. And so I'm working on a program for mobilizing energy management, which is getting applications that are energy aware into BlackBerries. So that's a good example. But at the end of the day, that device is going to have to authenticate to a utility portal or to a consumer network. And so that authentication piece is always going to be there. You're going to have strong security between your mobile device and the network and the endpoints it's talking to. And so that doesn't change in terms of how you'd want to design that. I guess getting the utilities bought in that they want to, what level of access and control they want to provide on mobile devices is the interesting question. I think everybody's very concerned about privacy issues when it goes to the consumer side of it. So that's one issue, is just getting access to data. You have to get basically governance bodies on board to say, yeah, we'll allow this. And it's different depending on what jurisdiction you're in. So in Canada was 5 years ahead in the smart grid or in smart metering, but they seem to be 5 years behind in terms of now that we've got this data, what rules and regulations are going to allow us to provide this to consumers.
Interesting. Chris, your viewpoint on that?
I think it's an interesting point because it raises just how broad level of the devices that need to interoperate today and the different security domains that are going to be affected by all, or that are implied by all those different devices. So I guess the only thing I'll add is that we need to develop firewalls between all of these different domains that allow the right commands to go back and forth and stop the wrong ones. And that's going to be an interesting challenge because those are the areas where there typically are a lot of attacks that are pretty subtle and hard to detect until one of our ethical hackers.
One of our ethical hackers. But was what they were talking about earlier this morning inbound to the smart meter, or was it from the inside of the house to the smart meter? In other words, is it the utility view through the concentrator to the smart meter, or is it coming in from the other direction? What do you think? Not sure about that.
Not sure about it.
Not sure about that. I don't know how many houses have smart appliances. Sammy, you might have a view on this.
I was not part of that discussion this morning, so I'm not really aware of that specific hack that
Well,
you're
I'm just
talking about.
I'm looking for the mobile. Sorry, jump back
Okay.
to the mobile thread for a
Okay.
second and how that might change things. You mentioned smart card, smart payment types of technology.
Yeah, so even phones right now have much higher level of security in their system in terms of, you know, identifying the user of that phone, and by that be able to send the bill to the right person, not impersonator. But right now they're getting into the next level with mobile payment. So as your phone becomes in Japan, your ticket to your train station, and in other, you know, part of the country, Google's announced recently as well that they want to do some type of mobile payment with their phone, and you'd be able to read all kind of different things. So they added a lot of security in it. But from that perspective, I still see that we need to isolate these two networks. On one side, the grid, you wanted to have, you know, this, you know, as isolated as possible, so you can protect against, you know, possible attacks, because it's a very sensitive network to a certain extent. On the general, you know, on the wireless and on the general Ethernet, there's, you know, so much, you know, different ways of attacking machines that if you start mixing the two, you'll, you know, create a lot of vulnerability on the grid.
Right.
It's not ready to be in the open
No, that's a
space.
good point. One of our panelists first thing this morning said that the way in is going to be through the blended attack. That's multiple methods, multiple points. But a subsequent panelist said something to the effect of that the cost associated, your return is higher by attacking the utility directly rather than trying to attack the home where you might get access to the local substation, right?
Mm-hmm.
You want to protect, obviously, the higher value, bigger failures. From a supply chain standpoint, we heard about the penetration testing in detail this morning. What are you guys doing with your ecosystems? We mentioned a little bit about the manufacturing side to make sure authenticity of devices and keys, but what else are you doing with your ecosystems to make sure that you're anticipating where this is going to go? Security being the moving target that it is. Chris, we'll start with you.
Well, we don't build silicon so much as we provide products that help secure that chain. So we're continuing to look at our products to make them more secure, especially when they're positioned into more hostile environments. So traditionally, in the past, our products have gone into friendly environments, which I guess we talked about, data centers and stuff. But as they get moved into contract manufacturers, where the employees of that manufacturing facility may not be working in the best interest of the product owner, become more hostile. So we're looking to up our product security, create procedures and roles around it to allow it to get deployed into that environment, and still protect the keys that are used to certify devices.
Super. By the way, we got about 5 minutes. If the audience would like to come up and present a couple questions, we can probably take those quick. Jim, same idea.
Well, I guess I had one to follow on your first question or the last question you had. But yeah, in terms of manufacturing in hostile environments, that's definitely something, you know, you have to look at the different agents in the supply chain and decide, are they friend or foe? And I guess assume that they're all foe. So that when you're building out your
Trust
your
nobody.
system, make sure that you're in control of that. On the mobile side, I thought the one interesting piece of this, I mean, absolutely you're going to see more and more mobile applications that have features that access the home, access applications in the home. On the one hand, I'd say, well, yeah, you know, most of those are kind of browser-based applications. You know, there are a lot of smartphone applications, but in one sense, you could say, well, they're no different than a PC application. The real difference is that there are billions of them, or hundreds of millions of them, and you need a system that can actually manage those and say, well, actually, if there's a bad egg out there, we need to be able to basically wipe it out. So that's the kind of platform that you need to basically, you know, you need a robust security platform in your mobile phone to deal with that threat.
We'll take Sammy's response and then we'll get to our audience question.
So I'll answer that with the different angle as well. You have companies like Cisco Systems and others that, you know, ship, you know, a lot of you know, routers, switches, and so on to critical you know, application, if it's military or like government related and so on. And a few years back, you know, we discovered that, you know, how would they be able to guarantee that the equipment that was shipped is really Cisco's? because they have contractors of contractors of contractors. So one way of securing the supply chain, and I mean, not, using Cisco name generally, most of the critical infrastructure OEMs do put the security chip similar to the one that we are promoting right now for the smart grid, like a device ID on every subboard. So every time that, you know, you put in an extra, you know, subboard or extra accessory that connects to your system, you authenticate it. You know that, you know, this is coming from me, not from some other vendors, and runs the right software, not some type of you know, Trojan horse software that's running on it. So it's very important to secure the supply chain as well. Not only that while in operation that the equipment operate as it should be, but the equipment that is shipped in and installed is the authentic one, not some knockoff that have Trojan horses in it.
Oh, it sounds so far-fetched, doesn't it, that you would get bad equipment from Cisco, but where's the Cisco equipment manufactured worldwide, right?
So
So
we
it's
go
not
with-
Cisco equipment, that's the thing.
Well, yeah, we shouldn't be
bought-
blaming Cisco, but let's assume the manufacturers even did their job. Now let's look at the support for that equipment over its lifetime. Let's
Yeah.
say you get a contract service provider, comes out and replaces a card in that certified piece of manufactured equipment, right? And all of a sudden, you've got a vulnerability problem. It's a huge issue.
So
Edward, yeah.
So secure supply chain is very important as well for the grid. You know, get to know like the equipment that's being shipped in and installed is the one that, you know, you're buying actually.
Absolutely.
So we take that a step further and actually recommend in really sensitive devices that you build that into the silicon. So we take it to, it's one thing to glue a chip ID onto a circuit board. It's entirely another thing to put it into the silicon where it's tamper-proof, and then you can provision that silicon and you effectively manage the life cycle of all the firmware in that device, including the debug, access, and controls, so that you can't basically start hacking at the chip, turn on the special debug features, and probe the innards of the chip.
Sure, which is what Travis has done outside, is turn on the debug features.